Greetings, ladies and gentlemen. We're just reviewing our chapter on rational expressions, rational equations. Here's a problem from the chapter review, problem 13 on page 586. And they asked us that, well, let's read them. The directions say, state the equations of the vertical and horizontal asymptotes for each rational function, and then graph the rational function. I might just summarize it a little bit shorter than that, since we are limited for time, tiempo, as they say. Let's first talk about actually domain and range, even though they didn't specifically ask for it. So the domain is the set of all x such that, and the range will be the set of all y such that some things hold true or not true. And for this, what values of x would break the function? Yep, x cannot equal -1 or +3. Right? All right. You don't get y? Like y? No, oh, the y. Okay, there we go. All right. Yeah, subtlety there. Yeah, the y is the trickier one. Now, because if I was to multiply this out, you guys agree there would be an x squared term here, right? And then some other things. And the numerator has no x term. And because the degree of the denominator for the x is higher than the degree of the numerator, I guess technically I could say there's an x to the 0, which is 1, right? Kind of. Since the degree is higher in the denominator, that means that for extreme values of x, y is going to be approaching 0, because this denominator is going to get bigger and bigger and bigger. The numerator stays relatively the same, in this case exactly the same. So dividing a small number by a number that's approaching infinity, that overall result is going to approach 0. So in this case, the y, well, the asymptote anyway, I might be careful about defining the range just yet, because the range is a little bit sneaky, but the asymptote can be found. We'll have x equals 3, x equals -1, and y equals 0. So this y equals 0 happens because the denominator's exponent is larger than the numerator's. Now, if it's a tie, if both of these were x squareds, then it is the ratio of their leading coefficients. So in this case, if this was x squared, 5x squared, and 1x squared, it would have been y equals 5. All right? Or if this was like a 2x squared, then it would have been 5 halves. Or if this was 10, it would have been 5 over 10, which is 1 half. All right? Something like that. And that's what happens when it's a tie for the degrees of the leading coefficients. So the range, I would expect, likely y cannot equal 0 is what the range is. However, I can't quite guarantee that because sometimes some weird stuff happens in between here. So let's graph these asymptotes. X equals 3 would be a vertical line somewhere at 3. So imagine 3 there. X equals -1, vertical asymptote at -1. And then y equals 0 is the horizontal asymptote. And then the rest of this graph I'd figure out from a chart, but it's probably something like this and like this. And then in between, you can have all sorts of weird, like it might even do a little crossover. And this crossover is why the range may not agree with the asymptote for the y. So I can't really know that until I know the graph. So in order to do that quickly, I'm just going to y equals 5 divided by parentheses x plus 1, close parentheses, x minus 3, yes. And let me make a table actually here. It's got the blurries. Here, let's see what's going on here. Let's see, let me do some table set. Set the table. Actually, my mom had me set the table yesterday for dinner. We were at my mom's house, just so you know. It was weird. It was like I had chores all over again. That's quite all right. Let's start at actually maybe -5, let's say. And we could count by 0.5s. And let's check this table. So if I'm looking at this, notice this is positive, 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 positive. Wait a minute, let me double check. Wasn't x not equal to negative 3? Oh, positive 3, that's why. I was about to say, I was like, what's wrong with this picture here? And as I approach negative 1, there's an error, and these numbers are getting larger and larger in the positive direction. So that confirms this portion of the graph for me. All right, so as I approach negative 1 from the left, that's what's occurring. As I leave negative 1, or as I approach it from the right, you can see these are negative. So I know this much is true. But I don't know if this loops around or if this does a cross just yet, so I'm going to have to analyze what's happening around 3 now. So let's scroll down. So it's undefined at 3, and then, aha, it goes negative as it approaches 3 from the left. So that means it is doing one of these little rupties. And then it's positive to the right of 3, so it is doing one of these guys. Now, depending on the height of this, technically I might have a range that is undefined for like this whole space. It's possible this could come all the way up and almost hit 0. That can occur as well. So my range is a little bit funky there. On the quiz, if you just said y is not equal to 0 in this case, I would be fine with that. But I just want to point out, technically, it's more likely. Actually, let's look at the graph here. Yeah. So yeah, this never gets higher than negative 1. So let's actually define the range as such. So since we have that information, you won't on the quiz or the test. So I would say negative 1 is less than y is less than or equal to 0. Right? So something like that. Maybe it's even equal to 1. I guess I could try to figure out what that height was if I really wanted to by checking the table. Tablature. Yeah. Let's see, how high does it get? In this case, it only gets up to negative 1.25. So maybe that's the case, but whatever. Using the, I think I can calculate a maximum point if I really wanted, but I never showed you how to do the calculator. So yeah, negative 1.25 is as high as it gets. So technically, negative 1.25 is what would go here. But don't worry about that. You're not going to get that detailed. We're just looking at general shapes of the graph. Okay? So yeah, so that's the idea for that. Let's look at one more real quick from the book. What do we got? ¿Qué es tu problema? Let's see.
Number
35. 35. I'll get as far as we can on it, but I'll at least outline the concept. Just to make sure we have enough time for the test here. Bing. So, oh, this, you know what? This one already has one of these weird little factor out of negative 1 from the denominator. So that's a sneaker right there. So let's, in order to subtract these two fractions, my general approach is I'm going to have to factor the denominators. I'm going to have to find the LCD. And then I will multiply each fraction, top and bottom, by the part of the LCD that it is missing. Notice there's no equal sign here. That's why I'm not multiplying both sides, quote unquote, by the LCD, because there are no both sides. There's no equal sign. They're all on the same side. We're all friends here. So this factors to be, this looks like m minus 3 all squared by the time that's all said and done. Here I can factor, like I said, out a negative 1, and that would be m squared minus 9. So that would be negative 1 times, what does m squared minus 9 factor to become? Yep, m plus 3, m minus 3. And then what I'd probably do with this minus sign is say, hey, let's make this a positive, and then just opposite this minus sign, making it a plus now. All right, so let me actually rewrite all this out. So this would be m plus 3 over m minus trace squared plus 8m minus 24 over m plus 3m minus 3. So the LCD in this situation, what's that going to be? M plus 3 has to be there, and M minus 3. I actually do need both of them, because if I just had one, this would only have partially canceled out with that LCD. So I need it to entirely cancel out. So I do, in fact, need both of them. So what would I multiply this fraction by, top and bottom?
M plus 3.
Yeah, that's missing the M plus 3. And this one I would multiply by what? M minus 3, because it's missing just one of those. And I would have to be careful just to make sure I properly distribute right in these tops and bottoms here. Well, in the tops anyway. The bottoms I'll actually leave factored because I won't have to do any more work with the bottom unless I get to cancel something out at the end, perhaps. And remember that we can only cancel stuff out that is factored. You can cancel out a factor of the factor. It would be illegal, for instance, to be like, oh, this m with this m squared would partially cancel out. Super illegal, so don't do that. And also some people would be like, oh, 3 and 9. 3 goes into 9 3 times. Can't do that unless it's all written as a product, right, of things, multiplication. So I think, unfortunately, that's all we can get time for today, going over the homework. So thank you for watching. Test time, I think.